All right, so we're going to do this one about cubic meters of air in a room that measures 8 feet by 12 foot by 10 foot. Tell me what am I finding with that? Volume, good job. I'm finding volume. So what is the volume of that room? And come on, don't use calculator.
8 times 10
What's the total volume? I'm sorry, say it again. I didn't hear you. Say it again. 960. The total volume is 960. That is the total volume. 960 what? Keep going. 960. No, look at the units, guys. Feet cubed. 960 feet cubed. If you aren't familiar with the little symbol for feet, that single apostrophe looking, that's the symbol for foot. So this is 960 feet cubed. 960 feet cubed. All right, so we are going to take 960 cubic feet and convert it into what?
meters.
Say it again. We're going to do inches cubed. Why are we doing inches cubed first? Because inches cubed can get us to centimeter cubed. Centimeter cubed can get us to what? What are we trying to get to? Meters. We're trying to get to meters. So centimeters cubed can get us to meters cubed. Okay? So how many inches are in a foot?
12.
12. So where is 12 inches going to go? On top. So 12 inches in 1 foot. And then what do we need to do to everything so that it will cancel? Not cube it. Good job. We're going to cube everything. So cube everything. 12 cubed, inches cubed, 1 cubed, foot cubed. If you don't know 1 cubed is 1, then go ahead and show 1 cubed so that you make sure you've cubed the 12. That's the key. What cancels? All the feet cubed cancel. So feet cubed cancel. All right. Now what do we go to? What is the conversion that gets us from metric to United States? 2.54 centimeters. Where's that going to go? On top. So 2.54 centimeters on top. What goes on bottom? 1 inch. And what do we have to do to all of that? Cube it. So 2.54 cubed, centimeter cubed, 1 cubed, inch cubed. Inches cubed, cancel. Yes?
Yes, and now we're at centimeters.
So now we're at centimeter cubed. What do we want to be in? Meter cubed. We want to be in meter cubed. Tell me.
Okay, hold on, I have it right here. Centimeters, meters, you said? I might have to use the hex stuff right now.
Good.
I might have to.
That's okay. Look, so let's look at it together. Where's base? Base is meter, correct?
Yes.
Base is meter. So what's the difference between meter and centi? How many steps? 2. So who's smaller? Thing. So it's 1 cubed, meter cubed, 10 squared cubed, centimeter cubed. That's where people get a little confused. Don't get confused. Does that make sense, what we're doing there? Okay. Now, do you remember what I told you when you take an exponent to an exponent or a power to a power? What do you do with those? So what does 10 to the second cubed really mean? 10 to the 6th. And that's what I will often do is just write that down so that I don't have to worry about it later. Now, you're in meters cubed. Plug it in your calculator. So what do we have? What do you get? Good. And that we can stop there. That's fine. Thank you. All right. How many significant figures do we need? We have to go back to our original numbers. But let me stop for just a minute. Did anybody not get this number? You did not? Okay, let me show you how to put it in. You ready? 960 times 12, and then hit that y to the x key. It's the caret key on your calculator. You've got that other one, so you use the caret key. 3 times 2.54, caret key 3, divided by 10, caret key 6. All right. Now, is this our final answer? No. We have to go back to original numbers. Not this 960. Go back to the original numbers. So how many do you have here? 2 here, 2 here, 2. So that's for sure 2. And then is everything else exact? Yeah. So what's my final answer? 27 meters cubed. Does that make sense? Talk to me, guys. Making sense? Okay, I left you with trying to do this one. But I'm looking at papers and I'm thinking, people aren't listening to me. You're not doing these. Guys, you got to do chemistry besides it 2 days a week. You're not going to pass if you just do chemistry 2 days a week unless you are good. And some people can because they've had this before. Whoa, that's not good, is it? Sorry. All right, so what do we do here? It says we're in centimeter cubed. What are we trying to get to? Gallons. We're trying to get to gallons. What is special about centimeter cubed? It equals 1 milliliter. So does that get us out of something that's length times width times height into something that's a liquid volume? Very good. So 1 centimeter cubed, 1 milliliter, centimeter cubed cancel. Now what do we know about centimeter cubed that might get us to gallons? Or milliliters, I mean, that might get us to gallons.
I know that 1 quart equals 946 milliliters.
That's exactly right. So what goes on top? 1 quart. And what goes on bottom? 946 milliliters. So milliliters cancel. Now we're in quarts. Somebody else tell me what we know. 4 quarts in 1 gallon. So 1 gallon on top, 4 quarts on bottom, quarts cancel, and now we're in gallons. Now, hopefully, and the problem with you all not doing this problem before now is now I don't have that big long number on my calculator. So instead of me potentially rewriting that in my calculator wrong, I'm going to do these numbers and multiply them. You can do it however you want to. What do you get for your answer on the calculator? Say it.
74.8.
So 74.89, yada, yada. How many significant digits do we need? We have to go back to original numbers. So this one had how many? 4. So we had 4 here. Keep going. 3 and 3. And then is all this exact over here? Yes. And the only thing, this one is 3 and everything else is exact. So what's my final answer? 74.9 gallons. All right. Did we talk about why you would want to know the volume of a water trough? Did I talk about that in here? I don't think I did. Huh? Well, this is the problem with it. Why would you want to know the volume of a water trough?
So you don't waste water.
Elaborate. It's going to overflow if you fill it up too much. So you turn the hose off if you're filling it up. But why would we want to know the volume of a water trough? When we're filling it up to know what? How much it's going to hold. Now, I'm talking a water trough on this problem. The swimming pool. Let's go swimming pool now. Have any of you ever had a swimming pool that you filled up and then maybe somebody in the family is like, dude, why is our water bill so high? And then, oh, we filled up the pool, didn't we? Oh, 20,000 gallons. Wow, who knew? That filled, when we put in pools, we all don't count the cost, literally, of what that thing's going to cost us. And so that's one thing. What if your pool leaks? Can that, then you have to add. So all of that would be one reason. Now, what about in agriculture? I've got ag majors. Some of you are ag majors in here. Why would this is truly a real problem. This is something I did. Now, I didn't measure it in 3 different units, but then I've converted it for you all. Why would I have needed to know the volume of my water trough?
How much an animal drinks or something?
It would help me. That would be one reason I would need to know. If I knew how often I filled it up, and I knew how many head of animals, whichever, goats, cattle, whatever they were drinking out of that trough, then could I get an estimate of how much each animal was drinking per day? Okay? Keep going with that now. Keep going with that. What else might I need to know the volume for? What else would we be using the volume of that tank for? Along those same lines, I'll give you a hint, sick.
How much, our temperature?
Probably not temperature that I can think of. My animals are sick.
How much medicine to put in there?
How much medicine to put in the water? Let me ask you a question. Do you think that there are times when we need to treat the water supply? The whole herd, do we have to ever do whole herd medical treatments? Are there situations where we might need to do whole herd medical treatments? Yes. You might give me an example?
Turkeys.
Turkeys, very good. Turkeys, chickens, potentially, yes. Very good example. Very good example where you might have to treat the entire herd. That's going to be a little different than a trough. They don't drink out of a trough, but that is definitely a very good example. Sounds like that's cool. Most people don't think of that. That is very, very true. What's another example? Now let me stop for just a minute though. I gotta address this. Please, those of you that are anti-meat and PETA people, please don't think that all animals are treated with medication, especially chicken houses and turkey houses, okay? Please don't think that. Farmers do not give their animals medication unless they need it. We're not wanting to just throw money away, okay? And if you want to talk about that, we'll talk. I'll be happy to talk with you about that. But that is a problem that people think. Media, YouTube is terrible about making it out like, oh my gosh, we're medicating all the animals. Why am I going to waste money medicating a well animal? I'm not going to do that. I'm not stupid. And so I like my money. I don't want to just throw it away. So, we do want to point that out. But yes, that's a situation. Where else? Let's go to hoof animals. Cattle or goats?
Yogis and cattle.
Say it again.
Yogis.
Say it one more. I'm not hearing you.
Yogis.
Tell me about it.
Well, then you'll have to break them a little harder before it comes back to hospital.
Okay. What animal?
Cattle.
Okay. So what's the medicine? Do you know? No? Okay. Have any of you ever had coccidia outbreaks? Anybody ever heard of coccidia? So you can treat individual animals, hopefully. We have goats. The reason I truly did that problem was because we had goats and almost all the goats had coccidia. And so we had to treat the whole herd. And rather than treat individually 50 goats, we put it in the water and treated the water. Now, we're talking goats, cows, turkeys, chickens. Let me ask this question. Is there anything we treat the whole herd of people with in our water supply?
Fluoride.
Say it again.
Fluoride.
Fluoride. That's exactly right. Did you know that we are treated, mass treated. Now, don't freak out, don't freak out. It's a good thing. It's a good thing. Have any of you ever lived in a state that did not treat, or a community that did not treat their water with fluoride? Have any of you? Where was it?
Mexico.
Mexico.
I got it from Springs and Mountains.
So you did not, now, did you, when you were, this is when you were a little boy?
Yes, ma'am.
Did your parents give you fluoride treatments or not?
No.
Have you ever had any teeth problems?
No.
Very good, very good, very good. Now, could your water have already had some natural fluoride in it? We don't know.
Yeah, maybe.
We don't know, we don't know. In Washington State, I had a relative living in Washington State. When her boys were small, they did not treat the water. And so every day she'd have to give her babies fluoride drops because, and why do we do that? Have you had that happen before too? You know about, yeah. And it tastes nasty. Nobody, I mean, it's very hard to do that, especially to a little baby or a little, especially like an 18-month-old who's going to spit it right back in your face. And so we just, you know, this community here in Warren County decided the best, in a lot of the United States, decided that the best way to help all people's dental health was to treat the water with fluoride. And so that's what they did. Now, does that mean that it's terrible for us? No, it's a very, very, very small amount. Now, obviously, we have a person who's lived to tell the story. He's gotten to this age, and he doesn't have any major teeth problems. So that's good. But again, we don't know exactly what was in his water. So, should you ever drink deionized water or distilled water? No. You know the jugs of water, the deionized distilled water? You should not drink that. Why? What does it have in it? Nothing. You need the fluoride. You need the minerals and the things that are in our water. So, now, are there situations where maybe there's things that shouldn't be in our water? Yes. And so will a water filtration hurt? No, not at all. Not at all. If you don't like the chlorine taste of water, that's not going to hurt to use that. But, so when we think of something like this, what I'm trying to get you guys to realize is when I do problems like this, not every problem, but honestly, a lot of the problems I come up with are problems that I have actually done myself for a purpose. It wasn't just some random thing. The pool situation, I had to calculate. When you go to start treating, we put a pool in during COVID. You put a pool in, and you've got to start adding chemicals to it. You got to know the volume of your pool. So you have to figure it out. You got to figure out the volume. So then you got to say, okay, I've got this many gallons. How much am I going to have to put of this and that? And it's something you have to figure out. And if you can do dimensional analysis, man, it makes it so much easier. It's so much easier to be able to figure this out and get so much more accurate with this information. So hopefully you're starting to see the realness of it. That's what I want you to be able to see, is the application in your life potentially. All right, density. So if I understand correctly, density, this is on your homework that's due tonight, this page is the last bit of information that you're waiting for to be able to finish that homework. I think there's like, 4 to 6 problems maybe of something that will help you finish this. So maybe you've already done it, and that's great. Density is mass per unit volume. Formula-wise, it's simply density is mass divided by volume. You need to learn that. M over V, that's mass over volume. You need to know that formula. You need to know how to calculate density. You also need to know the density of water. The density of water is 1 gram per milliliter. That is the density of water. Now, in all truth, that density of water is at 4 degrees Celsius. But we just say that the density of water is 1 gram per milliliter and just leave it at that for all temperatures at this point. And that works for what we do. What does the density of water, what does that really mean? Well, you remember my little pinky scenario, right? What's the tip of my pinky? 1 centimeter cubed, right? 1 centimeter cubed. So again, imagine I cut it off, hollow it out, pour water in it. It holds 1 milliliter, yes? With me? Okay. What's the mass? Water. What's the mass? 1 gram. Does that make sense? 1 gram. That's the mass. If I had 100 milliliters of water, what would the mass be? Come on. 100 grams. If I had 10 milliliters of water, what would the mass be? 10. All right, these, can I borrow that? These are 500 milliliter bottles. So, what's the mass? 500 grams. You with me? 500 grams. Now, let's think just a minute. Anybody able to tell me quickly about how many pounds that is? Well, wow, you're faster than one is what I was going to say. How do you know that? What's a pound in grams? 454 grams in a pound. Oh, by knowing, do you realize what you just did if you knew that? Immediately, what are you holding right here if it's full? Right about a little over a pound. Wow. You just learned something like, wow. Okay, then I can lift weights, right? Do my bicep curls with my little 1 pound weight. You ever carry a case of those? And that's how many bottles in those wrapped up thing? Are they like 24? How many pounds is that? Over 24 pounds. Oh, that's why that thing's so heavy. Are you getting it? Are you seeing, wow, okay, that kind of makes sense now. What's a gallon of water? What's the standard gallon of water mass? Some of you know this. You've heard this before. A gallon of water weighs about, have they heard those? How much?
7 pounds.
Every time I've ever heard people say 8 pounds. They would say 8 pounds. Well, let's figure it out. Since y'all don't know, let's figure it out. Let's look at the bottom of the paper. We've got, well, not on the bottom. I'm gonna flip mine. I want to know what a pound of water weighs. So we'll put 1.00 pounds. Now I'm actually going ahead here of what I was going to show you, but then you're okay getting this. Density has 2 units, yes? What are the 2 units for density? Grams per milliliter. A 2-unit number can be used for a what? Or as a conversion factor. And think about what's the unit for grams? A unit of what? Grams is a unit of mass. Milliliters is a unit of volume. Have we ever had a conversion factor on our list of conversion factors that allows us to convert from a mass to a volume or a volume to a mass? No, this is pretty huge. To be able to convert from a mass to a volume or a volume to a mass is pretty unique. That's why it's so cool to know the density of something. That's why I could do what I did with that water bottle, because and then it was easy because it's 1. So if we're in pounds, what are we going to convert our pounds to? To be able to use density as a conversion factor. Grams, good. So 1 pound on bottom, 454 grams. Okay. You know what? I started off, y'all are probably thinking, man, she's an idiot. We already know what this is. What I meant to say to you was a gallon. I wrote pounds, but I meant gallons, didn't I? I said gallons when I was saying the problem originally, and then I wrote pounds. Scratch that, rewind. We want to know what a gallon of water weighs in pounds. That's what I said that, and then I wrote the wrong thing. Now you're correct. Let's go to the proper problem. Let me write the problem so I don't get myself confused again. Mass in pounds of 1 gallon, 1.00 gallons of water. That's my question. Mass in pounds of 1.00 gallons of water. That's my question. Sorry, I messed myself up. Now, 1 gallon is what? 4 quarts. So gallons cancel. I'm going to be quiet. You answer this question. You solve it. See if you can figure it out. Use density as a conversion factor. Water is 1 gram per milliliter. Density of water is 1 gram per milliliter. See if you can figure this out. Try it, guys, come on, try it. Look at your conversion factor sheet and try it.
So we're trying to get that, we're trying to get the
You have to use density as a conversion factor. What are the units for density? Grams per milliliter. So what are you going to have to get quarts into? Here's where the problem is, I believe. You don't know what kind of unit quarts is. What kind of unit is quarts? Say it, volume. So what is a unit for volume that you need to get into? Milliliters, yes? You got to think in terms of what is this telling me? It's telling me volume. So what is a unit of volume in density? That unit is milliliters, so you have to get quarts into. So what is that?
144, 946 milliliters.
All right? Now keep going. Keep going. Try this. You all have got to learn to try things on your own without me doing it. Once you're in milliliters, what are you ready for? Grams per milliliter, density. That's the magic step that gets us from mass to volume, volume to mass. And so you are able to use density. That's the cool step right there. Once you're in grams, what do you go to? What are you trying to find? Pounds. How many grams in a pound? What is it again? 454 grams in 1 pound. So then run your numbers. And how many significant digits should you need in your final answer? 3, because this has 3, this is exact, this has 3, this has 3, and this has 3. So my final answer is what? Say it again. Come on. 8.33 pounds. 8.33 pounds. 8.33 pounds. Now, multiply that by 5. What do you get? Say it again. 41.6. So when you're picking up a 5-gallon bucket, how much water are you picking up? Depending on how much you slosh out, around 40 pounds, all right? Now, do you know how heavy that is? You ever picked up a 5-gallon bucket? It's hard to pick up just one 5-gallon bucket full of water, isn't it? It's much easier to pick up 2 5-gallon buckets full of water. Because then you're even. Otherwise, you slosh it and you're hitting it on your leg. And then you'd have to carry water when it was cold and it was frozen, and you sloshed it on your coveralls and your coveralls froze. So, that explains, does that help you see, oh, wow, now I understand. Now, where else could this be important?
Like maybe, well, if we're using gallons and stuff, like quarts, maybe how many quarts of maybe sugar?
Okay, typically we don't think of sugar in volume, though. We think of sugar in pounds. Let's go back to either a construction site or a farm. Say it.
Concrete.
Concrete. What do you have to carry? Have you ever seen, we had on our road recently, I hate to say it was funny, but it was kind I've not seen it happen. I'm sure it happens all the time, but I hadn't seen it happen before. A concrete truck slid off the road. Now think about a concrete truck,
You mean a cement truck?
a cement truck, a cement truck. Think about a cement truck. Is there a lot of mass going on there? On top of that, because they carry water and they carry cement. Both. And they themselves, the truck itself is very, very heavy. And on top of that, what is the truck constantly doing? Rotating. Rotating. I've never driven one and I don't ever think I could. Man, they have to be extremely hard to drive. Because let's think about just that 5-gallon bucket you're carrying. You carry that just one 5-gallon bucket. Now, have you ever carried a 5-gallon bucket of hydraulic fluid or oil that's closed up? Now that, let's pretend now, can I borrow your bottle? Let's just pretend now we take it and carry it like this. You ever carried one like that? Or kind of like you're hiking it up closer to your body to make it easier to carry? Does it shift? Does that liquid in there shift? Not that you're necessarily moving with the shift, but that's just around 40 gallons. Hydraulic fluid would be less than the 40 gallons because it's less dense. Now imagine that in a concrete truck that's rotating, is that already shifting? It's a wonder they're all not off the road when you think about that. Because now go to a farm or also a construction site, and what do we carry on trucks or trailers? A lot of what? For spraying. Water? You ever driven a water truck? Tell me what's going on in that water truck. It's sloshing. It's sloshing. So you're driving down the road, and if you make a fast turn, does that water make that fast turn with you? No, that water's still over there. Because until something stops it, makes it go the other way, and then it goes the other way, and, you know? Why now does that happen? Does it give you kind of, a gallon of it's 8.3 pounds. Whoa, I'm carrying, how many gallons you carrying? How much? 6,000 gallons? 6,000 gallons. Put 6,000 times 8.33. And divide by 2,000.
You said times 8.33?
Yep.
And divide by-
6,000 times 8.33 divided by 2,000. What do you get? 25 tons. 25 tons of water. Did you realize it was that much? Good for you. Good for you. Good for you. That's a lot of water. That's a lot of water. Oh, I think this week, let's go out in my field and carry that. Yeah? You want to get hung up. You see what I'm saying? Do we think about what weight we're carrying when we're like driving around? I got that tank of fuel in my back of my truck. If you're driving on snow, it's probably a good thing. If you're driving in a muddy field, is that always a good thing? No. Now, fuel is going to weigh different than water. Why? It's less dense. Oil will weigh less than water. Why? It's less dense. How do I know it's less dense? What do fuel, gasoline, diesel fuel, oil, hydraulic fluid do if they're mixed with water? Do they mix? They don't mix. Not when they're mixed with water, they don't burn. They will burn, but not when they're mixed with water. And some of them don't burn real well.
Air.
What do? Float or sink? Float. They float, which means they are less dense, which means 1 gallon doesn't have the same mass as 1 gallon of water. You follow? So now, when I say to you, know the density of water, do you see why? Because that helps you in life. It's not just because you have to learn this stuff in chemistry. If you'll stick with me, I promise you're going to learn a little bit more than chemistry. Or at least you're going to be able to see how you can apply what you learn to your world. And I think that's important for you to see. Chemistry is not all bad. I think most of the people that I scared off the first day probably have either warmed up to me or they're left. So that's okay, good. Now, let's go back to this problem. And something I just noticed, I did not give you just a plain Jane density problem on this page. I should have. Let me find just a plain Jane density problem for you, because I'm 90% sure you have one in your notes. I'm pretty sure you have, not notes, I'm pretty sure you have one in your homework. I'm not sure why I didn't give you one. Let me give you a density problem, a straight up density problem, because this is one also that's got a little extra thinking involved. So let me give it to you.
I think I can figure out this one.
All right, I'm going to give you a problem. Okay? A sample of coarse rock salt is found to have a mass of 11.7 grams. The salt is placed in a graduated cylinder filled with kerosene that has an initial reading of 20.7 milliliters and a final reading after addition of the salt of 26.1 milliliters. Calculate the density of the salt using the density formula. First of all, I want to know, why was the salt placed in kerosene? Okay, let me go backwards then. Let me go backwards. What's a graduate cylinder look like? Big open bowl or small thin tube? Usually smallish thin tube. Okay, calibrated, marked off. Okay, so let's think about what's going on here. You put the kerosene in the graduate cylinder, then you and you measure the volume, and it was 20.7 milliliters. You put the piece of rock salt in, and it rose to 26.1 milliliters. Anybody know the name of that process of finding volume? Displacement method. Where does that happen in real life? Where have you seen this little process happen? Not in chemistry lab, in your real life. Go home, get to the bathroom. Tell me what you've done. You ever fill the bathtub up with water? And then you fill it all the way to the top, and then you get in, and then what happened? It overflowed. Why? Because you have volume. You have volume. Did you calculate your volume being as great as it was? No. I want to take a bath where I can just really lay down and get all covered up. It's funny, isn't it, when it happens? And you're like putting yourself in there, and all of a sudden the water level goes, uh-oh. Why? Because your volume displaced the volume of the water. What did we use kerosene for instead of water? Come on, think. It's salt.
So it doesn't dissolve.
It wouldn't have dissolved. We don't want it to dissolve. So kerosene is a liquid. We put the kerosene in, put the salt in. Did it rise? Yes. Now, how do we calculate the density? What's the standard density formula? All right. How do we get the volume?
Well, I think we're going to do that 26.1 minus the 20.
You're exactly right. Because this is the initial volume, this is the final volume, and the difference is 5.4 milliliters. Now, significant figure-wise, is this correct? One place after the decimal, one place after the decimal? Yes? So, what's our mass? 11.7 grams, and our volume is 5.4 milliliters. What's our density of this? And honestly, I doubt if this is really the density of rock salt, but it might be. I don't remember. I think I just made all this up. So what do you get using proper significant figures? How many significant figures do we use?
2.2.
Good job. Very good. 2.2 grams per milliliter. Very good.
So how do you do that? 11.7
11.7 divided by 5.4, And then you have 3 significant figures, 2 significant figures, so your answer gets 2. Okay? Question on this.
So that would be 2.2.
All right, now then, go back to this problem. You have already seen me do a problem almost identical to this with our problem we just calculated with water. Except this time we're not starting in gallons. What are we starting in? Cups. Now, this problem is a totally goofy problem, just so you know. If you know anything about engines, when you get to the end of this, you're going to be like, wow. Let me just give you, for those of you that are like, man, this is a dumb problem. Why did she even do this? Let me explain why I did this. Do you know how cars will be in like 3.2 liter or 4.1 liter, etc.? So and it's not at all what this really is, okay? It's not at all what this is, but what I did was take one of those numbers, convert it to cups, and then do this. What this really should be more of a problem for is if I had a solid block of aluminum, that had a volume of 20.2 cups, what is the mass? That's what you're really finding out here. It's really not an engine block, because an engine block is not solid, okay? So it's a goofy problem. Those of you that know that, you're like, now you know, I know this is not real, okay? Start it. Do this problem. You should be able to look at the problem you already did with water and do this problem on your own. I'm gonna let you totally spend about 3 minutes and see what you can get done on it. Look at the other one we did. Did you get it already? Look at the other problem we did that's the same kind of thing. Okay? Use it to help you. The one that we just did on gallons. The gallons of water. The steps are pretty much the same. Guys, use the problem that we did on gallons of water, except that you're gonna have to start off, and you also need to have your conversion factor sheet out if you don't know your conversion factors.
We have the cups to, that's why.
Okay, so what's our given? Say it again. 20.2 cups. Folks, if you have a choice, I've said this before, if you have a choice between a 1 unit number, and a 2 unit number, what is your given? 1 unit number. Write that down if you haven't remembered that. If a 1 unit number or a 2 unit number, given is 1 unit. The given is going to be the 1 unit number. If you have a choice between a 1 unit number and a 2 unit number, the given will be your 1 unit number. All right, cups is what kind of unit? Volume. That's what you have to tell yourself. What kind of unit is cups? It's volume. So cups is going to be converted to something to get me eventually into milliliters, because that's what density is in. So what am I going to convert cups to? Cups to pints. How many cups in a pint? 2 cups in 1 pint. Cups cancel. What is pints going to be converted into? Quarts. How many pints in a quart? 2 pints in 1 quart. Pints cancel. What do you know about quarts? And something that might go with density. Say it. 946 milliliters is equal to 1 quart. So 946 milliliters is equal to 1 quart. Quarts cancel. Now what do we know? We know the density of aluminum. What is the density of aluminum? 2.7 grams per 1 milliliter. Milliliters cancel. Are we now in grams? And then grams to what? Pounds. How many grams are in a pound? 454 grams in 1 pound. So grams cancel. Now we're in pounds. Run your numbers. All right, what do you get on your calculator? Good. All right, go back to original numbers. How many significant digits are here? 3. How many here? Don't count. Don't count. How many? Come on. How many are here? 3. Good. How many are here? 2. Here? 3. What's my final answer going to be? 28 what? 28 pounds. Now, I'm going to fuss at some of you because some of you are not even starting the problems. And some of you are obviously, you don't know your conversion factors. Okay? Guys, if you do not know your conversion factors, which are found on the syllabus, if you don't know those, you're hurting yourself. I mean, I cannot make you learn these. But I can tell you, those of you that know your conversion factors are doing much better than those of you that don't know your conversion factors. It's obvious. It's obvious. So you have to know these. You have to spend time on chemistry. If you are totally lost on dimensional analysis right now, then you need to take the time to watch the extra practice videos that are on Blackboard. They're about 10 minutes long, and the worksheets are under extra practice worksheets. You also need to take the time to say, hey, Miss Brooks, I need some help. You also have people all around you. Almost every one of you who I'm watching are writing after I already knew the problem. There are people sitting next to you who are already done. It's okay to say, hey, can you help me get started? Talk to your neighbors and friends. Get to know these people. Chances are you're going to see these people the rest of your college career. So get to know them, okay? I'm not saying cheat. I'm saying you have people around you that know what they're doing. Ask, okay? Question on this problem. Yes? Run it through again. Run it through again, okay? Just run the whole thing through again. Use one finger on your calculator. Don't forget to divide, divide, divide on the bottom. All right. Now, the rest of this is double unit conversions and then other problems that are more complicated. Lucas, if you can't get it now, just calm down. I'll help you at the end of class, okay? Just let's go to the next one, okay? All right, so let's do double unit conversion problems. We're going to look at double unit conversion problems. Okay, go back to my pinky. Cut it off, hollow it out, pour in 1 milliliter of water, and it's 1 gram. Do any of you have a concept of what 1 gram feels like? I don't. I don't have any concept of what 1 gram feels like. I don't have any concept of what 2.7 grams feels like. I don't have any concept even of what 19.3 grams feels like. Now, I will say I have an advantage because I do give my goats copper oxide, and I do have a balance at home, a triple beam balance, an old one maybe you had in your high school, and I do get a mass of 2 grams or 4 grams of copper for the goats and give it to them. So I do have an idea. But as far as a real life all the time, I know what that feels like. I don't. Now, what if I said to you, do you know what a 50-pound bag of mineral feels like? Some of you can say, yeah, I know what a 50-pound bag of mineral feels like. What if I said, do you know what a 5-gallon bucket of water feels like? Yeah, now you know that's 40 pounds, right? Do we understand grams like we understand pounds? No. Well, you go to the store and you buy a 5-pound bag of flour. You know what that feels like? You've held a baby that weighs 7 pounds, a newborn. You know what that feels like? We know pounds, we don't know grams. So knowing that the density of gold is 19.3 grams per milliliter, okay, it's more dense than water, yes. It's more dense than aluminum, yes. But do I really have any concept of how dense gold is by that number? Not really. I know it fits there, but I don't know what 19.3 grams feels like. So sometimes it's best to convert density into units that we understand what they feel like or look like. And so that's with a double unit conversion problem. Meaning we're not just converting 1 unit, we're converting both units all in the same problem. And that's where some of you want to do two separate problems, and I don't want you to. You need to learn how to do it all in one problem. So in this situation, if you look at my little comment here, if a 1 unit number or a 2 unit number is given, or is there, then the given is the 1 unit. In this case, though, do we have a 1 unit and a 2 unit? What do you have? Only a 2 unit. So the 2 unit is what you start with. That is the given. And why do I know that? Because look at what the problem says. The problem says I want to convert grams per milliliter to pounds per foot cubed. Is grams a unit for mass? Is pounds a unit for mass? Yes. Is milliliter a unit for volume and foot cubed a unit for volume?
I don't think so.
Yes. Foot cubed is. Milliliter and foot cubed are units for volume. So what are we going to convert grams to? What do we know about grams to pounds? What is it? 454 grams in 1 pound. Grams cancel. Now I'm circling pounds because I already have pounds. I'm done at the top, but I'm not done with the problem. So I'm saying pounds is what I needed. Good job. Now I'm going to skip over this step. Skip it. I'm going to look at milliliters. I want to get milliliters into something that's cubed. What do I know? You've done this already today. Everybody should know. What is it? 1 centimeter cubed. So 1 milliliter is 1 centimeter cubed. Does milliliter cancel? Yes. Now what am I in? Centimeter cubed. Now what do I know about centimeter cubed that would eventually get me to feet cubed? Centimeter to inch. 2.54 centimeters is 1 inch, so I put 2.54 cubed. Keep going. Centimeter cubed over 1 cubed, inch cubed. Centimeter cubed cancels, and I've got inch cubed on the bottom. You do the last step. You do the last step right now. You've got it on another problem. That's what we did. The first problem we did today was something like that. Look at the previous page in your notes and you'll see a problem we did that was just like that. Or not just like it, but very, very similar. What goes on top? Exactly what goes on top. 12 cubed inches cubed over 1 cubed foot cubed. So inches cubed cancel. Now I'm in foot cubed. Run your numbers. Tell me what you get on your calculator.
1,203.77.
Good job. What are those units? Pounds per foot cubed, but we're not going to round it yet. Before we do any rounding, I want you to look at the floor. Look at the floor. What is that floor tile? It's a 1 foot by 1 foot floor tile. All right, so you got that measurement in your head? 1 foot, 1 foot, 1 foot. You with me? 1 foot by 1 foot by 1 foot. Is that a very big box? Not really. Just a tiny little box, really. A 1 cubic foot box. You know what I'm saying. A 1 cubic foot box. A 1 cubic foot block. Anybody going, oh my gosh. Anybody saying that in your head? You ought to be saying that if you know what you just did. What did you just determine that this 1 cubic foot box weighed? 1,200 pounds. No big deal. I'll just steal some gold. Just walk out. I will gold. Guys, are you thinking what you just figured out? 1 cubic foot. A relatively small box. A relatively small box, if it were pure gold, would have a mass of over 1,200 pounds. 1,200 pounds. This row, the second row of people, add one more person to it. Squish them all together into a 1 cubic box, and that's what you have. Think I can do that? I don't know their weights for sure. I'm just making a big guess here, okay? And honestly, it might take 9 of them. But if I put them in a box, do you follow what I'm saying? That's insane, isn't it? Now, tell me about gold. Gold is very dense. Do you get that now? Does that kind of give you a real idea? Now, let's go to the movies. Television shows and movies. Have y'all ever watched those movies where they're going in, they're stealing gold? You ever seen those movies where I don't remember what movie it was. It might have been a Lethal Weapon. I don't remember. There was an old movie where they were stealing gold. They went through, James Bond, I think he does it all the time or something. There's different movies where they're stealing gold, and these gold blocks are about the size of tissue boxes. Do you think they're probably just, let me just take it out like a football? No, but they make it look like that. Isn't that funny? They haven't done the math. They don't have a clue. The gold, there's no way. There's no way. There is a story, if you're a historian, I don't remember, I don't remember which tribe it was. It may have been I don't remember. Was it the Aztecs that were super wealthy with gold? Anybody remember that? And somebody wanted to steal all the gold, and they put it in their pockets, and then they had to swim through the moat, and they sunk. Because they didn't equate how much that was going to weigh when they did that. Because they couldn't, it was so heavy. But we don't realize. Now, that's the answer. I stop all that before I do significant figures because I want you to realize what you just figured out. Because I think that makes it so real. Oh my gosh. Now, significant figures is the issue on this problem. How many significant digits do you have here? Keep going. Keep going. Exact. 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 Guys, they're in the exact column. These are defined quantities. They're not rounded numbers. So my answer can only have 3. That's my 3. Does that 3 make the 0 go up? So if I write it as 1,200, is that correct? No. How many is that? How many significant digits is this? 2. How many significant digits am I supposed to have? 3. What if I put a decimal at the end? That would be 4. How must I write this number? How do I have to write it? Tell me. Keep going. Units. Pounds per foot cubed. That is your final answer. That is your final answer. All right, lot in that problem. A lot to realize in that problem. I'd go back and do that problem on my own sometime. All right, the next one is convert 45 miles per hour to feet per second. All right, so it's another double unit conversion problem. What you're given? 45 miles per hour. So 45 miles over 1 hour. See if you can do it. Go ahead if you would like. Just answer it. Go all the way through. Don't, not if you like, try it. All of you try it. Try to answer it all the way through. Same thing we just did. Know your conversion factors. Find that sheet if you don't know them. What do you know? You've got to get miles to what? Feet. Miles to feet.
I got that.
Keep going. Got the answer? Good. Wait just a minute. Let everybody finish. Try it. All right, tell me what we know about miles. 5,280 feet. So 5,280 feet in 1 mile. Miles cancel. I am now in feet. What do we know about hours?
3600.
If you know that it's 3,600 seconds per hour, you can put that. If you don't, then it's 1 hour, 60 minutes. Hours cancel. 1 minute, 60 seconds. That's the answer, sorry. All right, so there's your seconds. Or if you put 3,600 seconds per 1 hour, that's fine. If you know it just off the top of your head, that's fine. All right, so run your numbers. So 45 times 5280 divided by 60, and you get what? Come on. 66. How many significant digits do you have here? 2. How many do you have here? Exact. So the answer is exactly what you get, which is feet per second. Now, let me ask you a question. If I told you that I drove 45 miles per hour, would you think, man, that's fast or slow?
Slow.
You'd say it's slow. I don't like driving 45 miles per hour. I like driving a lot faster. Now, some of you do too. This is my speech on get off your cotton picking phone when you drive. Okay? Get off your phone when you are driving. 45 miles per hour does not seem fast, does it? You all said no, right? Okay, I want to show you something. I measured this one day. Guess what this distance is?
32.
What is it? Come on. 66 feet. A little echo over here. Let's see. Does that sound good? 66 feet across this room. So, on your mark, get set. 1,000. Did you see me get across there? 1,000. 1,000. 1,000. What? Ah! Crash! And that's 45 feet per second. Or 45 miles per hour, rather. Is 45 miles per hour slow? No. No. 1,000. 1,000. Do you see? And you're telling me, oh, I'm going to drive 95 miles per hour. You're an idiot. I like you. But you're an idiot when it comes to driving if you're driving 95 miles per hour. And then happy you are watching a video while you're driving 95 miles per hour. You kill somebody, you're going to feel a little like an idiot. Okay? Get off your phone and quit driving so fast. Now, real quick, because because I got to do more work. I'm going to tell you a funny story. When I taught this lecture one day, when I say this stuff, I preach to myself. I like driving fast too, okay? But I've gotten a new app with Kentucky Farm Bureau called the Drive Right app, and I like to look at my score, and I don't like to get below a 90, so I've been doing better, okay? But I gave this lecture when I was teaching in Glasgow, this same class one day, and I left Glasgow's campus. Get off your phone now, buddy. You're not on your phone. You're on your calculator. Sorry, I'm getting all over you on phone stuff. I'm driving out of Glasgow. If any of you have ever been in Glasgow's campus, there's a 45-mile-per-hour speed limit when you leave Glasgow's campus. I think it's Trojan Trail. And then you're going around, and there's a little guardrail there. And this is the day I gave this lecture. And I'm a good card-carrying member of Gas Buddy and Speedway. And so I wanted to see where gas was cheaper before I headed back to Bowling Green. So being, the cool person I am, and I'm oblivious to what I tell other people to do, I am driving my 45 miles per hour along Trojan Trail in the afternoon when they're letting school out. And I am looking at Gas Buddy. Because, I've got to get cheaper gas. And all of a sudden, what am I hitting? The guardrail. So I immediately swerved over and I taught myself a lesson that day. So God works in really good ways with me. I'm pretty dense, and eventually he knocks me over the head or hits a guardrail. So when I tell you these little funny things, it is the truth. Okay? So get off your phone and just remember, when you're driving 45 miles per hour, this room, 1,000. Okay? You can kill a kid that fast. Okay? Be careful. All right, on this one, I'm going to give you the hint, and then I want to talk about temperature conversions before we leave. On this one, there is a given and there is a conversion factor in the problem. What is the given? What is the given? Say it again. 30 days. 30 days is the given. What is the conversion factor? 22.5 gallons in 12 hours. Okay? I'm going to let you do that one on your own. Now, real quick, let's talk about temperature conversions. Told too many stories today. Let's talk about temperature conversions. You can do that one on your own. Do it before you come back. Do it before you come back. Temperature conversions, add this to your I need to know thing. Degrees Celsius plus 273 is Kelvin. It's the absolute temperature scale. It does not have degrees, and there is no negative temperature. Have you ever heard of absolute zero? Absolute zero is 0 Kelvin. That's what that is. It's 0 Kelvin, okay? And then you need to know degree Fahrenheit equals degrees Celsius times 1.8 plus 32. So, solve this problem. 70 degrees Fahrenheit equals degrees Celsius. Solve it. Using this formula, solve it right now. If you can't find X, which is what you're doing there, you probably need to consider not being in chemistry right now. If you can't do this little bit of algebra, this is pretty simple 6th, 7th grade math, so you should be able to do this. Find degrees Celsius. I'm going to tell you round to nearest tenth. I didn't tell you how to round. I didn't tell you use significant figures, so I'll tell you round to nearest tenth in this. What do you get for your answer? 21.1. For those of you that don't remember this, that's where I'm struggling with you being in here if you can't do it. Minus 32 on both sides, that leaves 38, equals degrees Celsius times 1.8, divide both by 1.8, and you get 22.1 degrees Celsius. Now, what do you get for a degree, or for Kelvin rather, with no degree? It's 273 plus what? It's 22.1, so that gives you 295, or 294 rather, I'm sorry, 294.1 Kelvin. 294.1 Kelvin. All right, do the other two real quick. Go ahead. Is it 20? It is 21.1. Y'all got to tell me. You got to tell me 21.1. Very good. 273 plus 21.1. Good. Sometimes I have to make mistakes to make you all pay attention. Good. 21.1. All right, I'll let you go. Do these other two. They're even easier, okay? Or you can stay and do them if you want. Drive slowly.